So we already did this problem yesterday. I realized the second hour yesterday that I, for some reason, had lost my mind just for about a few seconds. And I think a few of y'all noticed what I did at this point. Because yesterday at this point I divided by 2, yes? I don't even know what I was thinking, because and the only reason I noticed it was when I was setting up or redoing the key. I did the exact same thing, plugged it in to check it, and realized it gave me the wrong answer. It was really what I'm doing, it was just saying 1/2 divided by 2 is 1/4. It's not 1. So really what we should have done instead is just multiply both sides by 2, telling us x is 8 pi over 3. We should have done the same thing over here. We should multiply both sides by 2, telling us x is 10 pi over 3. And again, we could plug this back in to check to make sure that they work, because you could plug 8 pi over 3 back into the original formula or original equation and see, does it give us 0? If it does, awesome. If it doesn't, then it's not the right answer. The same with 10 pi over 3. Just making sure it's in radians, so 2 sine alpha y equals enter. Alpha y equals enter. So one of our answers was 10 pi over 3. So I could say 10 pi over 3 all over 2 plus second square root 3. We get 0. We could do the same thing, but replace the 10 with, delete 8. Okay, those are the correct answers. Does that make sense? So you can plug them back in and check it. With some of these here, you can use the graphing calculator to check them. I'd use the 30XS. I'd use the yellow one, because for some of the stuff here, it's easier to type these in a lot faster, especially when we're doing fractions of fractions. So, questions on this here? As I know, this is where we made it to today. Now, are there any other questions or something that you saw or wanted to look at from 1 through 52 that we didn't cover yesterday? Morning. Now, there's only one type of problem you won't really be able to check in the calculator, and that's when we're dealing with, say, cotangent. Because the main way we type cotangent into the calculator is 1 over tangent. And there are certain values that we know that tangent's going to be undefined. Because tangent's going to be undefined whenever cosine is 0. So cosine 0 at pi over 2 and 3 pi over 2. So if one of the answers is pi over 2 and we try to calculate that, there's a good chance the calculator will throw it out. Even if we do, a second. So tangent of pi divided by 2 to the negative 1 is going to throw the value out, because it's going to try to take the value of tangent of pi over 2, which is undefined at that point, to apply it. But cotangent at that same value is 0. Does that kind of make sense? So just wanting you to be aware of that. Questions on 53 or 54 or 55? 53, 54, or 55? One of those that y'all want to see worked. 53. Now with both of these here, there's 2 routes we could go about this. 2 different ways we can go about this. One is we can apply our angle addition postulate, so the angle sum and angle, the difference of angles, or we can use our product to sum or sum to product formula. Either one will work just fine. Because we can say, since we have two angles here being subtracted, which I'll write this off to the side just so we have it up here, sine of u minus sine of v is equal to 2 times sine of, make sure, u plus v over 2 times sine of u minus v all over 2. Really didn't need that extra parenthesis. So what this is telling us is this here, this whole side here is 2 times, doing that again, 2 times sine. Okay, I'm glad I'm looking back at that because this needs to be cosine. Because sine of u minus v is 2 cosine of u plus v times sine of u minus v. Okay, good. So 2 cosine. So this is u, this is v. So we're going to say x plus pi over 6 plus x minus 7 pi over 6 times sine of x plus pi over 6 minus x minus 7 pi over 6 is equal to the square root of 3 over 2. Well, here we can combine like terms. X plus x is 2x. Pi over 6 minus 7 pi over 6. So we're looking at really 1/6 minus 7/6, which is just -1. In our case, it's just going to be minus pi. Which, has that really helped us at all? That's made it, I feel like that just made it more complicated. Do y'all agree with that? I hate having to do this, but cross that out. Let's see. The reason I did that is I thought that it might be a little bit easier to work that way, but it looks like it's not. Because if we do it the other way, here, sine of two angles being added together is going to be sine, because this is sine of our u plus v, is equal to sine of u cosine v plus cosine u sine of v. So we'd have sine of x cosine of pi over 6 plus cosine of x sine of pi over 6. Minus. We'll have to put the second one in parentheses because the negative will distribute to both terms. And for this one here, we're going to have sine of x cosine of 7 pi over 6 minus cosine of x sine of 7 pi over 6 is equal to square root 3 over 2. This here is a little bit easier to work. Because if we look at this here, especially with the unit circle, put that, we can start simplifying some things. Because cosine of pi over 6 is square root 3 over 2. So we have square root 3 over 2 sine of x plus, well, sine of pi over 6 is 1/2. 1/2 cosine of x minus, here cosine of 7 pi over 6 is negative square root 3 over 2 sine of x minus sine of 7 pi over 6 is negative 1/2, which is going to make that plus 1/2 cosine of x is equal to square root 3 over 2. I'd say this is a lot easier to work than what we were just dealing with, yes? So we needed to apply this negative to both terms. And if we do that, well, we have square root 3 over 2 sine of x from the beginning. This one here is now going to become positive square root 3 over 2 sine of x plus 1/2 cosine of x from here. Well, the negative times the positive is going to make it negative 1/2 cosine of x is equal to square root 3 over 2. Wait a minute. What happens to these two here? These are 0. They're gone. Because 1/2 minus 1/2 is 0. So it's gone. Now over here, we are going to have sine of x. Square root of 3 over 2 plus square root 3 over 2. We have how many square root 3's over 2's? 2 of them. So it's 2 square root 3 over 2, which is just square root 3. Now, because they're being multiplied together, we can divide both sides by the square root of 3. These will simplify out. And this here, luckily, the graphing calculator will do this one. Y equals enter. Second square root 3 over, second quit. Second square root 3 over 2, divide it by second square root 3 is 1/2. And because this is restricted on the interval of 0 to 2 pi, we just need to look at our unit circle and see where it is. 1/2, which is pi over 6, and pi over 6. Questions on this here? Yep. All the ones with solving, I'm going to put it between 0 and 2 pi. I'm not going to make you add the 2 pi in or do any of that. It's always going to be between 0 and 2 pi. Questions on these here? So on all of these here, so for these two here, I would definitely use our angle sum and angle difference properties to solve these here, because we have 2 of them where we do have something different in the angles. And again, for this one here, I would still use our angle sum angle difference property, our angle sum property for this here, and work it from there. Any other questions on these 3 here? We feel good with these here? Questions on 56 through 59? Questions on these here? There's not going to be one as challenging as 57, I can guarantee that. Huh? 56? So 56, this here is applying our double angle formula. That's what we're going to need to do. So the double angle formula, sine of 2u, here sine of 2x is equal to 2 times sine of x cosine of x. And it's still being multiplied by sine of x is equal to, let's do cosine of x. Now we can multiply these two together, which will give us 2 sine squared of x. Cosine of x is equal to cosine of x. At this point here, we need to get everything on the same side. So we'll subtract it. Notice that we have 2 sine squared of x, cosine of x minus cosine of x is equal to 0. So we tried to get everything on the same side, and now not everything is in terms of sine and cosine, but do we have something in common with both terms? Yes, we have cosine, so we can factor it out. So we can say cosine of x times 2 sine squared of x minus 1 is equal to 0. And again, we have two things multiplied together to equal 0, so one of them must be 0. Luckily for us, finding out where cosine of x equals 0 is not too bad, because here x is pi over 2 or 3 pi over 2. Now for the other one here, we would first add 1 to both sides, telling us 2 sine squared of x is equal to 1. Then we would divide both sides by 2, telling us sine squared of x is 1/2. So really we added 1 divided by 2, we get this here. And at this point here we can square root both sides. And the square root of sine squared is just going to be sine of x is equal to plus or minus. Well, the square root of 1/2 is going to be square root 2 over 2. And because of the plus or minus, we have, and that this is between 0 and 2 pi, we have all the values of square root 2 over 2 for sine of x. So we have pi over 4. We've got 3 pi over 4. We've got 5 pi over 4, and we have 7 pi over 4. So we have all these here.
Aubrey Hicks, come to the office. Aubrey, come to the office.
Questions on this here? Any questions on any of this so far? And I mean, if we wanted to, we could graph this to see what it is. Cosine of 2x, sine of x, minus cosine. Clear. So sine 2x, sine of x minus cosine of x. Graph. Well, let's make the window zoom 7. Well, we can see that it does cross 1, 2, 3, 4, 5, 6, 7 times possibly. Second trace value of 2 pi. So we see 1, 2, 3, 4, 5, 6 different spots. But it does cross between 0 and 2 pi. 1, 2, 3, 4, 5, 6. I just plug in a value of 2 pi to get where 2 pi ends. So I know from the y-axis to where that point is, that's where all my values should be. Now we could, again, if we do second trace value and plug a value in, say pi divided by 2, okay, we can check the values there. Now with tangent inverse, or tangent to the -1 with our cotangent, if it does work. It'll be a little funky. It won't give you a y value. Second, well, tangent of x to the -1, our cotangent. So we have this here. So that's supposed to be pi over 2 where it's crossing, I believe, which is 0, yes? It shows us it's 0. It shows us it's crossing the x-axis. So I can go second trace value, pi divided by 2. It doesn't give us a y value. It gives us a value, just doesn't give us a y value. And tangent is 0 at pi. So second trace value pi. Yeah, it's like it's trying to give you a value, but it won't work. But so pi over 2, if you put the decimal in, it'll tell you that it's 0. But it's weird. It doesn't want to do it. So sometimes for these here, just plugging it straight in to the normal calculator like we did before, we'll check those. '60 through 62, I can't remember the other set of problems I said not to do. Okay, so I did say these here. Rewrite each expression using the double angle formula. So if we look at sine times cosine, the double angle formula that matches up with is sine of 2x, which is equal to 2 sine of x cosine of x, yes? But does it match up exactly? Well, no. This here has a 2. This one doesn't. So what I could do is divide both sides or multiply both sides by a half divided by 2. So those are gone, leaving me with just the sine times cosine, which means sine times cosine is sine of 2x over 2 is what this is. Or we can say 1/2 sine of 2x. Those are the same thing. So for some of these here, we have to manipulate the formula just a bit to get there. Like the next one is supposed, because we have cosine squared of x minus 1/2. Well, one of the formulas for cosine of 2x is equal to 2 cosine squared of x minus 1. Well, to get this here, really, they multiply both sides by 1/2. So this here is actually 1/2 cosine of 2x. So is it making sense how they're getting to these here? So one of the biggest things you can do with all of these problems is rework or redefine those so that they look like the formula. Because if we look at sine, this next one, well, cosine of 2x is equal to 1 minus sine squared of x, because that's what we want. Now, if I look at this here, well, and make sure, I think sine's supposed to have, yep, supposed to have a 2. So this 10's supposed to be a 2, this 5's supposed to be a 1, yes? Sine's supposed to be negative, and the 5, where the 5's at, supposed to be positive. So what can I do to make this go from positive 10 to negative 2? We can divide it by 5, yes? Negative 5. I can factor a negative 5 out. If I factor a negative 5 out of 10 sine squared of x, well, it's going to be negative 2 sine squared of x. If I factor a negative 5 out of negative 5, I get plus 1. Does that make sense of what we just did there? And the reason I did that is now if we look at the general form, we have positive 1 and negative 2 sine squared of x, yes? Do they match up? So that means now I can say negative 5 And this whole thing can be replaced with cosine of 2x, and that's our answer. So I would manipulate the formulas to get back to where they are and then go from there. And on all these here, I took whatever the angle was and multiplied it by 2. So if one of these had been 2x and 2x, or all the x values were 2x, well then we'd have 4x because we're multiplying it by 2. Any questions on any of these here? (63) and 64, find the exact value of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. I'll just pick this one here. And again, all this is setting up our triangle. It should be theta. Now they tell us sine of theta is -1/2. Opposite over hypotenuse. Now at this point here, we can use Pythagorean's theorem. A squared plus -1 squared is equal to 2 squared, or a is equal to the square root of 2 squared minus -1 squared. 4 minus 1, so we get square root of 3. So the adjacent side is square root of 3. Questions on this here? And we know it's positive because we're in the positive x-axis. Now, the rest of this is just applying the formulas. So sine of 2 theta is equal to 2 sine of theta cosine of theta. Well, sine, we already have, is -1/2. Cosine is going to be adjacent over the hypotenuse. So square root 3 over 2. At this point, multiply it together. Just multiply it together. You can plug all this into the calculator and get negative square root 3 over 2. So that's our sine of 2 theta. Cosine of 2 theta. You have your choice. You have absolutely your choice on which one you want to use, because cosine of 2 theta is equal to cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. It doesn't matter which one we pick. So you could pick 2 cosine squared of theta minus 1. Well, cosine, we found is square root 3 over 2. Squared minus 1. And again, at this point, I would type that straight into the calculator exactly as you have it. Because square root 3 over 2 is going to be 3 over 4, which is going to end up being 3/2, which I believe is going to give you a half. If square root 3 times square root 3 is 3. 2 times 2 is 4, so 3/4. 6/4, which would be 3/2. 3/2 minus 1 should give us a half. Yep. Now, if you have the formula sheet out, so I'll put that cosine 2 theta. We can use the tangent formula. Tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared of theta. But what do we know about tangent? Tangent is sine over. So what we could say is tangent of 2 theta is our sine value over cosine. And we can plug that straight into the calculator and let it do it for us, which should give us negative square root of 3. So really, once we find sine and cosine, tangent's not too bad. It's just plugging those two values over the top of each other, and we are Done. Questions on this here? We good with this here? Yeah, 64. 65, I realized 65 and 66 I didn't even put on here. 67, 68, so none of these are on the test. Neither one of those. 72, 73, these are on the test. Rewrite as a product to sum. Straight from the book. Because the formula for this here, so sine times cosine, is going to be our 1/2 of sine of u plus v. So we're going to add these two together, x plus y plus x minus y. Then we have plus sine of u minus v. So this would be x plus y minus x minus y. And again, it's not asking us to solve, it just wants us to rewrite it and simplify it a little bit. Here, x plus x is 2x. Y minus y is 0, so we have sine of 2x. Plus, sure I'm not going crazy with this here. Plus, so here we have x minus x, which is 0. Y minus negative y is going to be sine of 2y, because really what we have here is x plus y minus x plus y if we distribute that negative through. If we wanted to simplify it even more, I need that last one, but exact same thing. Either one of those are the same thing. Questions on this here? We feel okay with this? Just using the formula, plugging in our information. We good with 72 and 73? We ready to look at the last two? What can we do for these here? Plug them in. Plug them in. We can plug them in, and we will get the exact same value. I mean, it is possible for us to get 0. It'd be kind of frustrating, but it is possible. Sine minus, yep, so cosine of pi over 4 plus 3 pi over 4 all over 2 times sine of 5 pi over 4 minus pi over 4 all over 2. And again, when I was working these out, I really just, if we had to do it this way, I just ended up typing those into the calculator and let it doing it for us, for me specifically. Because this here, it ends up being 8 pi over 4, and 8 pi over 4 ends up being 2 pi over 2 sine. 5 minus 3 is 2 pi over 4, which is pi over 2 over 2, which ends up giving us 2 cosine of pi times sine of pi over 4. Well, that's 2 times 1 times the square root 2 over 2. It's actually -1. Delete negative. Square root of 2. And I think that's probably what the calculator gave you. That's it. So one of the biggest things I would definitely say for Monday, have your unit circle, because that's going to be handy to have. You don't necessarily, well, I would about to say don't necessarily need it. It was going to be very helpful, because otherwise you'll have to use sine inverse or cosine inverse or tangent inverse to find some of the angles, and it's only going to give you one of them. Then you're going to have to use your reference angles, figure out where the other angle is supposed to be. This here will give it to you for the most part, because you can match it up and figure out where it's at. Your reference sheet, I would definitely make sure you have your reference sheet for all these formulas, because otherwise you're going to have to memorize them all. There ain't no point in that. Use your reference sheet. Okay? And if the angles look funky, check it to make sure it works. Most of the time, you're not going to have extraneous solutions. The only time you're guaranteed to have extraneous solutions is if you have to square both sides. We have to square both sides, then extraneous solutions are most likely going to come out. Does that make sense? All right. With that, we are finished.